coming to one more important test of the series, positive series, there's something called comparison test, which all of you are aware of. That is, if I have comparison, the name itself suggests that if I have two series, one is summation un, other one is summation vn, which are a series of positive terms. Then if I take their nth term ratio, mind you, remember the only mistake that students do is they'll be considering summation also when applying limit. Please don't do that. We are considering the ratio between the nth terms of the series un and the series vn. So un and vn only I will take as n tends to infinity. If I get the value of the limit to be L, and if that L turns out to be finite and non-zero, then both summation un and summation vn converge or diverge together. That means what? One of the series characteristics I will be knowing, using which the other one I will predict. Okay. Again, for comparison test, there's one test that will be very much useful for the students. That is the P test or the P series test. That is what? If we have summation 1 by n power P, which is a series, something like 1 by, if P is equal to 1, it is 1 by 1, 1 by 2, 1 by 3, like that. If I have P is equal to 2, it would be 1 by 1 squared, 1 by 2 squared, and 1 by 3 squared, like that. And then if I have P is equal to 3, then it would be 1 by 1 cube, 1 by 2 cube, and 1 by 3 cube, and so on. Okay. The series looks like this. This is 3 cube, not 33. Okay. So the series looks like this. Now, what the test says is for P greater than 1, the series converges. And for P less than 1, the series diverges. That's what the P test says. Okay. If you remember P test, then it can be extensively applied. Now here what I will do, since I have already made a mention of absolute convergence and conditional convergence, I'll be applying this to an alternating series for checking absolute and conditional convergence. Okay. Which it is the comparison test, where inbuilt or inside comparison test, I'll be needing p-test as well. Okay, guys? Yes. I'll be taking an example here. That is what? Test for absolute or conditional convergence. Conditional convergence. Okay. Of the series is like this. That is minus 1 power n plus 1 under root n plus 1 minus under root n. Okay. And then n is starting from 1 to infinity. Okay, that's what is being given. Once I have minus 1 power n or n plus 1, I'm sure that this is an alternating series. Guys, make it a point to write that it is an alternating series. That will fetch you some marks. Okay, even though if your test goes wrong or if you mess up something, that point will fetch you marks. It's an alternating series. It's an alternating series. Then I will know certain things, that Leibniz test is the only test that I can apply, dot, dot. Also, when it's an alternating series, if I have to check for absolute convergence, I can go with modulus. Okay. So what I will be doing, I'll be considering, it's an alternating series. What I will do is, I will consider the absolute series, that is summation. Okay. First thing what I'll do is, I'll assume that this is un and then talk about remaining things. Let summation minus 1 power n plus 1 un. This is equal to what? Summation minus 1 power n plus 1 under root n plus 1 minus under root n. Okay, this I'll be considering. Now I'm clear what is my un, right? Now what I will do for applying absolute, for checking absolute convergence, I'll be considering summation mod un. Once I put modulus, this minus 1 power n plus 1 vanishes off. Okay, so I'll be having under root of n plus 1 minus under root of n. Guys, remember, whenever I have n in the numerator, I'll have a problem when as n tends to infinity. So for which there's a root as well. So for which I'll be rationalizing. Okay. I think I am clear. What I will do, I'll consider the nth term first. N in the numerator causes difficulty, or it will make the term infinite or undefined as n tends to infinity. Hence, I will go with rationalization, since there is also root associated with the nth term of this series. Okay. So what I will do is immediately I'll be rationalizing it. Root n plus 1, root n into root n plus, how will I rationalize? If I have negative, then I'll be doing it with positive. Why? Because a plus b into a minus b results in removing the root, a square minus b square. Okay, I'll be squaring it, so root can be removed. Okay, now a minus b into a plus b. So I'll be having what? Under root of n plus 1 whole squared minus under root of n whole squared by, in the denominator I have an n, as n tends to infinity I don't have problem with the nth term. Okay, this root n squared goes off. So I'll be having n plus 1 minus n by root n plus 1 plus root n. Okay, this minus n and plus n gets cancelled off. 1 by root n plus 1 plus root n. Okay, this is what I have in un. Okay, now as we have discussed comparison test, and this doesn't have factorials, for this positive series I can go with comparison test. Okay, for which I'll be needing n par p value. How I'll choose n par p or summation vn? Whatever is the highest term that's there in un, that will be become the p value. Okay, whatever is the highest nth term power, that would decide my summation vn. I think I'm clear what I'm talking about. I'll just show you here. I'll be taking out n from the root, so I'll be having root n here from the first term. So under the root I'll have 1 plus 1 by n. Actually inside the root it is n, but when it comes outside the root it would be root n, guys. Okay, that from the first term. From the second term, I have root n as well. Okay, so two root n's I have. I'll be taking common from a plus b. 1 plus 1 by n under root plus 1. Root n I have taken now. So what would be my p? This is what is remaining in un. 1 by root n, or 1 by n power 1 by 2 is remaining in un. Okay, that will formulate my v. Okay, that will formulate my v. What is that? I'll be choosing. I'll write a strong sentence here, that is, choose summation vn to be 1 by n par p would be what? 1 by 2. Now, what's the value of p, guys? P is equal to 1 by 2, which is less than 1. So, what does p test say? P test says that if p is less than 1, then the series diverges. For, I will write here, I don't write all the conditions, I just write the condition what is applicable here. Okay, for p less than 1, by p test, what happens? Summation vn diverges. That's what I have about summation vn. That means what? I have the information about summation vn, with which I will get the information about summation mod un as well. Okay. Now, next what I will do, I will consider the ratio, because for applying comparison test, I'll be needing the ratio between the nth term of un and nth term of vn. Okay. Nth term of un is what? 1 by under root n root of 1 plus 1 by n is what I have, plus 1 by vn is what? 1 by n power 1 by 2 or root n is what I have. 1 by root n gets cancelled off. 1 by root 1 plus 1 by n plus 1 is what I will have. Okay. Now apply limit n tending to infinity. See what happens. Mod un by mod vn. No, mod un by vn only. Un doesn't need a mod. It's not an alternating series. Okay. So limit n tending to infinity. What I will have? 1 by under root of 1 plus 1 by n plus 1. 1 by 1 plus 1 as n tends to infinity goes to 0. Okay. So 1 by under root of 1 plus 0 plus 1. So if you want, I can just write here, guys. This is, of course, root n I have taken common. So it's just 1 only, not root 1. Okay. Since limit n tending to infinity, 1 by n goes to 0. Okay. So I'll be having this value to be 1 by root 1 is 1 and 1. So I'll be having 1 by 2. 1 by 2 is the value of L. Here, for a comparison test, things are different. What happens? The limit is finite and non-zero. I need not check for greater than 0, less than, greater than 1, less than 1 and all. Finite and non-zero. It should be just that. Please remember, this is the difference between comparison test and ratio and Rebbe's test, guys. Don't get confused. I make a note here strongly. Don't get confused between comparison test condition and ratio and Rebbe's test. Ratio and Rebbe's test demands for L being greater than 1 for convergence, L being less than 1 for divergence. Okay. But comparison test wants L to be just finite and non-zero to conclude things. What I will say, I already know that summation Vn is divergent. Hence, by comparison test, both will converge or diverge together, right? So, summation mod un also diverges. Please see here, summation Vn is diverging. So, I won't write everything, anything and everything of the test. I will write what is needed. What that is I'll make the mention of the test that I am using here now. By comparison test, summation un diverges. That's it. It's obvious to the examiner as well as to you what exactly comparison test is. Okay. For more obviousness, I have written that the limit is finite and non-zero. I did not mention everything about the test. Okay. Yes. I'll just stop this video here. Of course, now, since it is diverging, what will I say? See what's happening? Yeah. I just have lost track in explaining you certain things. That is, mod un is diverging, guys. So, by comparison test, mod un diverges. So, what will I say? Summation mod un is not absolutely convergent. It is what? Conditionally convergent is what I will conclude, which is very important in the question. Look back the question once again. Summation mod un is conditionally convergent is what I will conclude. I think I am clear, guys. I think I am clear. I've got that summation mod un is diverging. It's not converging. So it is, I made a remark, right? What that is I made a remark in the previous video. That is, if mod un diverges, we say it is non-absolutely convergent or semi-convergent or conditionally convergent, because of which I will conclude like this. Okay. Yeah.